Hi guys, we're looking at lesson 8 today where we do the same thing where we're proving angle relationships. But first we'll do a little bit of review over lesson 7. Okay. Justify the statement with a property of equality or a property of congruence. Well, we have segment AB congruent to segment CD and segment CD congruent to EF. That's our hypothesis. And we need to justify the conclusion that AB is congruent to EF. The thing that justifies this is the transitive property. We transition from AB to EF because both of them are equal to segment CD. Okay? Once again, justify the statement with a property of equality or a property of congruence. We have segment RS congruent to RS. Okay, we have the same thing that is congruent to itself. We're not transitioning. We're not mirroring. This is reflexive. Okay, justify the statement with a property of equality or a property of congruence. If H is between G and I, then GH plus HI is equal to GI. Okay, once again, no transition, no mirroring. This is not equal to itself. In fact, we have two segments that are being added together to equal a larger segment. This is segment addition postulate. State a conclusion that can be drawn from the statement sorry guys. State a conclusion that can be drawn from the statement given using the property indicated. The statement is W is between X and Z, and we need to use the segment addition postulate. Okay, this is similar to what we saw before when we had the segment addition postulate being the reason for the particular statement. We need to add two parts together to create the whole. That is B. W is in the middle. So I have two small segments, XW and WZ. When I put those together, they are equal to the larger segment XZ. State a conclusion that can be drawn from the statements given and using the property indicated. Here we have LM congruent to NO and NO congruent to PQ. And we need to use the transitive property. Okay, transitive means that I'm going to be transitioning from the first to the last because both of them are equal to what's in the middle. So I should have segment LM congruent to segment PQ. Okay, and then going back a little further, given that B is the midpoint of segment AC, what do I know to be true? Well, if B's in the middle, okay, segment addition postulate, AB plus BC is equal to AC. Okay, so we've identified and used special pairs of angles in the past. Now we're going to write proofs that involve the supplementary and complementary angles. What's supplementary? Well, supplementary is when I have two angles when put together that equal 180. Complementary is when I have two angles that, when added together, equal 90. We're also writing proofs involving congruent and right angles. Congruent meaning same measure, and right angles, of course, being 90 degrees. So now we add some additional postulates. There's a protractor postulate. Okay, if I have an angle here where I take the ray BA, one side of the angle, and place that along 0, then the measure of this angle ABC, B being the vertex, okay, that's the center of the two rays, that measure will correspond to a positive real number. Okay, you see in this case that A is located at 0, and I'm going around the outside of the protractor from left to right to measure this one to be, it looks like about 146 degrees. Okay, postulate 211, I have an angle addition postulate similar to segment addition, but in this case we have the measure of the angles. It says D is in the interior of ABC, that angle, if and only if the measure of angle ABD plus the measure of DBC equals the measure of the whole thing, ABC, the two of them put together. Okay, it says using a protractor, a construction worker measures that an angle a beam makes with the ceiling is 42 degrees. We need to determine what the measure of the angle the beam makes with the wall. Okay, so normally ceilings and walls are at a 90-degree angle from one another. I think we'll make use of that information. Okay, the ceiling and the wall make a 90-degree angle. We'll let angle 1 be the angle between the beam and the ceiling, and angle 2 be the angle between the beam and the wall. Okay, the measure of both of those angles when added together equals 90. This is the angle addition postulate. I know that the measure of angle 1 between the beam and the ceiling is 42, so I can substitute that in. And now I can solve for what the measure of angle 2 is by subtracting. I use subtraction property of equality to subtract 42 from both sides, and then substitute once again so that the measure of angle 2 is found to be 90 minus 42, which is 48. The beam makes a 48-degree angle with the wall. So let's see if we can do the same thing here. We have an angle 1 and an angle 2. We need to find the measure of angle 1 if we know that the measure of angle 2 is 58. And the measure of both of those angles put together, that's measure of angle JKL, is a 162. Okay, measure of angle 1 plus 58 is equal to 162. Subtract 58 from both sides, and we're left with that the measure of angle 1 is 104 degrees. You can check that work by adding 58 back to 104, and you should end up with 162. We also have additional theorems. There's a supplement theorem and a complement theorem. The supplement theorem states if two angles form a linear pair, if together they make a line where their outside rays are going in opposite directions, we know them to be supplementary angles. In 2.4 for the complement theorem, if the non-common sides of the two adjacent angles form a right angle, then the angles are complementary angles. Together they form an angle that is 90 degrees. So now we're making use of those two theorems. It says at 4 o'clock, the angle between the hour and minute hands of the clock is 120 degrees. When the second hand bisects the angle between the hour and minute hands, what are the measures of the angles between the minute and second hands and between the second and hour hands? Okay, first of all, make a sketch. It really helps a lot. Okay, the time is 4 o'clock. The second hand is bisecting the angle between the hour and the minute hand, so it is going to be pointing towards the 2. Okay, this one looks a little bit off, but remember, sometimes our diagrams are just to give us an idea and aren't necessarily the most accurate. Okay, so we have this diagram. Okay, let's use the angle addition postulate and the definition of an angle bisector in order to determine what our angle is. Okay, since the angles are congruent because of the definition of an angle bisector, we know that each angle is 60 degrees. Okay, both angles are 60 degrees. We're able to take angle addition postulate saying that the two of them together will equal the 120 degrees. And we use the definition of angle bisector to know that that's going to cut the larger angle exactly in half. So we have two angles put together, 60 degrees and 60 degrees. Okay, so we're going to justify using that angle addition postulate to check your answer. Okay, the sketch we drew helps us determine an appropriate solution method, and our answer is reasonable. Here's another example. The diagram shows a square for a particular quilt pattern. Okay, this is just one square within the quilt. We have an angle BAC, that's that first beige part, which equals the measure of DAE, which is the beige part on the bottom. And we know that BAE is a right angle. From that information, we need to determine what is angle CAD. Now, we know that BAE is a right angle, so that's 90. We know the measure of the two beige parts. We can subtract those away from the 90 degrees. What are you going to be left with? 90, subtract 20 more. You should be left with 50. Even more theorems, more reasons added to our cheat sheet. Okay, just like we had equality and we had segment congruence, we can also have angle congruence, but we still have the reflexive property of congruence, the symmetric property of congruence, and the transitive property of congruence, all involving angles. Okay, so angle 1 congruent to angle 1 is reflexive. Angle 1 congruent to angle 2, and then angle 2 congruent to angle 1 is symmetric. That's that mirror image. Transitive, angle 1 congruent to angle 2, and angle 2 congruent to angle 3. So angle 1 is congruent to angle 3. We transition from beginning to end. There's also this proof about the symmetric property of congruence. We're given that A is congruent to B, We need to prove that. So they provide a paragraph proof rather than that two-column proof that we've been doing recently. We have to be a little patient to make sure that we read through this. We are given that angle A is congruent to angle B. That's that given. Next, we need to state our reasoning behind the next statements. By the definition of congruent angles, their measures are equal. Measure of angle A is equal to measure of angle B. We can then use the symmetric property of equality to flip that around. The measure of angle B equals measure of angle A. And we know that angle B is congruent to angle A by the definition of congruent angles. Okay, two more theorems. Congruent supplements theorem. Angles supplementary to the same angle, or two congruent angles, are congruent. We also have congruent complements theorem, that angles that are complement to the same angle or congruent angles are congruent. Okay, make sure that you print out a copy of the formula and postulate reference guide, where all of these are available for easy reference. Okay, here they give us a two-column proof of the congruent supplements theorem. We know that we are given that angle 1 and angle 2 are supplementary. If we put those together, they're going to equal 180 degrees. We also know that angle 2 and angle 3 are supplementary. You put those two together and they will equal 180 degrees. We need to prove that angle 1 is congruent to angle 3. So we list our two givens. Okay, and number 1, that's the two given statements, and the reason is that it's given. Given the definition of supplementary angles, I can state that the measure of angle 1 plus the measure of angle 2 is 180, and the measure of angle 2 plus the measure of angle 3 is also 180. Then using substitution, I can say that the first statement in 2 and the second statement in 2 are equal to each other since they're both equal to 180. Okay, we know that measure of angle 2 is equal to measure of angle 2, given the reflexive property. And then I subtract the measure of angle 2 from both sides so that I'm left with, in 5, measure of angle 1 is equal to the measure of angle 3. And then lastly, using the definition of congruent angles, I know that angle 1 is congruent to angle 3 as their measures are equal. Okay, here's another proof using congruent, complementary, or supplementary theorems. Here in the figure, angle 1 and angle 4 form a linear pair. And we are also given that the measure of angle 3 and the measure of angle 1 will equal 180. We need to prove that angle 3 and angle 4 are congruent. Okay, so we start off with our givens and what we need to prove. We're given the linear pair and we're given what equals 180. We need to prove angle 3 congruent to angle 4. So let's set up the statements and the reasons. Start off with your givens. We know that angle 1 and 4 are supplementary because that's the definition of a linear pair. Okay, angle 3 and angle 1 are supplementary because of the definition of supplementary angles. And therefore, angle 3 is congruent to angle 4. The angles are supplementary to the same angle. They're both supplementary to angle 1, so therefore they are congruent. Okay, in this figure, we have angle NYR and angle RYA, which form a linear pair. And on the other side, AXY and AXZ also form a linear pair. And we are told that RYA and AXZ are congruent. We need to prove that NYR and AXY are congruent. So we need to figure out which completes this proof. Okay, first off, they state the givens. Then they state that NYR and RYA are supplementary, as they form a linear pair, and that AXY and AXZ are supplementary because they form a linear pair. Okay, also given is that RYA and AXZ are congruent. And as a result, how do we get to NYR is congruent to AXY? Did we use substitution? The definition of a linear pair? That the angles supplementary to the same angle or to congruent angles are congruent, or the definition of supplementary angles. Okay, RYA got replaced by the NYR that it formed a linear pair with. AXZ got replaced by AXY, which it also formed a linear pair with. So we've replaced these with the angles that were part of their linear pair. This is that angle supplementary to the same angle or to congruent angles are also congruent. Okay, vertical angles theorem. If two angles are vertical angles, then they are congruent. Okay, we knew this before when we first were introduced to vertical angles, but now there's a theorem to back that. So let's use vertical angles. If 1 and 2 are vertical angles, and the measure of angle 1 is d minus 32, and the measure of angle 2 is 175 subtract 2d, we need to find the measure of angle 1 and angle 2 and justify each step. So we know that we are given that angle 1 and angle 2 are vertical angles. Therefore, they are congruent by the vertical angles theorem. Because they are congruent, we know that the measure of angle 1 is equal to the measure of angle 2 because of the definition of congruent angles. So I can substitute in the equations for their measure. D minus 32 is equal to 175 minus 2d. So now we have an algebraic equation where we can solve for d. Okay. We use the addition property to get to 3D minus 32 is equal to 175. Addition property again. 3D is equal to 207. Division property, which is now dividing by 3 to get D equal to 69. So now we know what D is. Where do we go next? Well, we need to really substitute that 69 back in for D. Okay, the measure of angle 1 was D minus 32. So that's going to be 69 minus 32. The measure of angle 2 is 175. Subtract 2D, so that's 175, subtract 2 times 69. So I'm left with measure of angle 1 is 37. And the measure of angle 2 is also 37. They are congruent. If angle A and angle Z are vertical angles, and the measure of angle A is equal to 3B minus 23, and the measure of angle Z is 152 subtract 4B, we can use that same method as we just used to find the measure of angle A and angle Z. Okay, vertical angles are congruent to one another. We can start off with 3B minus 23 is equal to 152 minus 4B. Gather our like terms using addition and division. And we get to the measure of both angle A and Z are 52. We already could have ruled out choice A and choice D because the measures were not congruent and vertical angles are congruent. Another series of theorems. Like I said, print this out so that you have it for easy access. Perpendicular lines intersect to form 4 right angles. That's theorem 2.9. Theorem 2.10 says that all right angles are congruent. Theorem 2.11, perpendicular lines form congruent adjacent angles. 2.12 states that if two angles are congruent and supplementary, that each angle is a right angle. And lastly, 2.13, if two congruent angles form a linear pair, then they are right angles. Okay. Your homework for Monday is found on pages 156 and 157. There is 9 through 15 odd, and I think it's supposed to be 16 through 26 all. Be careful and check that over in what I put in Google Classroom. But this is the last video that you're going to need. Remember to comment if there's any questions or concerns about something that you need some direction on. I'll see you guys on Monday.